We will now do a problem where we add vectors using the component method. The first vector, we'll call it vector A, 47.6 meters at 32.6 degrees. So using the component method, we have to resolve all the vectors into components. The easiest way to do this is to draw each of the vectors on its own set of axes. So here's vector A. Little set of axes, x and y. 32.6 degrees is in the first quadrant, so we have 47.6 meters, 32.6 degrees, and then we'll draw the x and y components. Here's ax, here's ay, and using trigonometry, ax, 47.6 meters cos 32.6, ay, 47.6 meters sine 32.6. Then just using your calculator, we will get for ax 40.1 meters and for ay 25.6 meters. When you do this, you should check the algebraic signs of your components. Since we have a first quadrant angle, both components should be positive in the first quadrant. Since we did this for A, let's do it for the other two vectors. Vector B was 74.9 meters at 159.8 degrees. This is going to be a second quadrant angle. Let's draw B. X and Y. 159.8 degrees. 74.9 meters. Now, when we're over here, we can also draw this reference angle, which when you add it to the standard angle will give you 180 degrees, 20.2 degrees. There's BX pointing to the left and BY pointing up. So normally when we work, or when you think of looking at a triangle, we look at the small triangle. Let's see what happens when we find components this way. You need to be extra careful. For BX, if you do this, 74.9 meters times the cosine of 20.2 degrees, you would get 70.3 meters. The magnitude, 70.3, is fine, but it should not be positive in quadrant 2. Looking at the picture, BX points left, which should be negative. The problem occurs when you use the reference angles, these first quadrant angles. They will always give positive trig functions. So when you use these reference angles, angles between 0 and 90 degrees, you may, on occasion, have to add a positive or negative sign based on which way it points. So you have to look at the picture. Ahead of time we knew BX was negative, we got positive. We have to slap a negative in to make sure we have the right answer. Now, how could you avoid slapping a negative in? You could have also got the same answer by doing 74.9 meters times the cosine of 159.8 degrees. Notice in your calculator you'd get negative 70.3 meters without having to add an extra negative. When you take trigonometric functions of standard angles, the positives and negatives come out in the wash, so you have to be careful. You may have to add negatives when you use reference angles. Don't add extra negatives using standard angles. All right, you'll end up getting double negatives. So by looking at that, we could also figure out BY. Ahead of time we know BY should be positive because it points up and it's in quadrant 2. 74.9 meters sine 20.2 or 74.9 meters sine 159.8. Either one would give you 25.9 meters positive. Now let's move on to vector C. C was 81 meters at 247 degrees, a third quadrant angle. Same approach. Here's vector C. We're going to be down in the third quadrant, down here. So there's 247 degrees, which makes this 67 degrees, 81 meters. And your components: CX to the left, CY down. So both of them will be negative, and you can get them this way. CX is either 81 meters cos 67 with a negative in front of it, or 81 meters cos 247. Either way, negative 31.6 meters. CY, 81 meters sine 67 with a negative in front of it. It is in quadrant 3 and it points down. Or 81 meters sine 247. Either way, you'll get negative 74.6 meters. Now, remember what this means. We add vectors by adding their components. To visualize what all of this means is we are going to add these vectors by doing this. It would look something like this. AX, AY, followed by BX, BY, followed by CX and CY, all at right angles to each other, where there's the resultant. If you remember from the previous example, we could find that resultant simply by adding components. So we don't want to skip any steps. To find the x component, resultant in the x, AX plus BX plus CX. Write everything down. When you add those together, negative 61.8 meters. RY, AY plus BY plus CY, negative 23.1 meters. Remember, these are the components of the resultant. Please, please, please do not skip the next step. Draw the picture or you may end up getting the wrong angle. So this says our resultant will look like this. The x component is 61.8 meters to the left, or negative x, followed by 23.1 meters down. So here's the resultant. Theta, the angle we want, but we'll find that by getting the nice reference angle, phi. So let's find the magnitude of r by Pythagorean theorem first. Magnitude of r, square root of negative 61.8 meters squared plus negative 23.1 meters squared, which is 66 meters. To find the reference angle phi, phi is the inverse tangent of 23.1 meters over 61.8 meters. Notice, no negatives. We are pretending this is a first quadrant angle. Reference angles have to be between 0 and 90. When you do this, you get 20.5 degrees. Since we are in the third quadrant, the standard angle theta is 180 degrees plus phi, which is 200.5 degrees. So our answer, R, is 66 meters at 200.5 degrees. The best thing about vector addition problems, they're all performed the same way.